Hello students, welcome to first PUC Physics online class. So last class we discussed the concept of the Cp, Cv as well as gamma for the monoatomic molecule. Now we have to discuss value of the molar specific heat as well as the gamma value for the diatomic molecule. That means they are rigid rotator. Rigid rotator word is the meaning entande they are not vibrating. Without considering the vibrational mode, some diatomic molecule will have the vibration mode also along with the translational as well as rotational degrees of freedom. But we have to consider the diatomic molecule having only without having the vibrational degrees of freedom. ಅದಕ್ಕೆ ಯಾವುದೆಲ್ಲ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು ಅಂದರೆ H2O2 they are not vibrating even at the normal temperature. Now for that let us consider the diatomic molecule. Consider diatomic molecule at a temperature T. At a temperature T. Now we know that the energy associated with each translational and rotational degrees of freedom. Each translational and rotational degrees of freedom. What is the value? According to the law of equipartition of energy associated with each vibrational as well as each translational as well as rotational degrees of freedom will be equal to half a kBT. We know this concept. Now, diatomic molecule will have the without having vibrational mode. Without having the vibrational mode, has 3 translational and 2 rotational degrees of freedom. So 3 translational and 2 rotational degrees of freedom. ಹಾಗಾದ್ರೆ ಇದಕ್ಕೆ ಇರುವಂಥದ್ದು ಈಗ ನೀವು 3 ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಮತ್ತು 2 rotational. Monoatomic molecule will have only the 3 translational, whereas a diatomic molecule will have the 3 translational as well as 2 rotational degrees of freedom. Now, hence we can write it as the formula for the average energy now. And hence the average energy value that should be equal to 3 translational. ಒಂದೊಂದು translational degrees of freedom is energy half kBT. ಹಾಗಾದ್ರೆ 3 ಆಗುವಾಗ 3 into half kBT. And ಇನ್ನೊಂದು 2 rotational. It will have the 2 rotational degrees of freedom. Therefore, 2 into half kBT. That should be equal to 3 by 2 kBT. The plus 2 to get cancelled kBT. Taking kBT outside. So therefore, 3 by 2 plus 1. 3 by 2 plus 1 kBT. That should be equal to 5 by 2 kBT. So this is the value of average energy now. And if we write this is average energy for the one molecule, and if we write it for the 1 mole, for 1 mole of molecule, for 1 mole the total energy value, what is the total energy? Total energy I will indicate it as a U. One molecule is 5 by 2 kBT. In a 1 mole there are Avogadro number of molecules. So therefore, for the total energy of the diatomic molecule, that should be equal to 5 by 2 into Na into Kb ಅದು into T, where Na is Avogadro number. ಅದು actually calculate ಮಾಡಿದ ಮೆಥಡ್ ಹೇಗೆಂದರೆ ಹೀಗೆ ಇದು 1 molecule in average energy value that should be equal to 5 by 2 kBT. And if we consider for the Na number of molecules, Na is Avogadro number, for this number of molecules what is energy? So therefore, on solving with cross multiplying we get the required this term. So this is for 1 mole the total energy value 5 by 2 Na into Kb into R. And what is the formula for the Na into Kb? Na into Kb that will indicate the R. So therefore U that should be equal to 5 by 2 RT. You have to remember this formula. So that should be equal to 5 by 2 RT. And hence what is the formula for the Cv now? Cv, molar specific heat at constant volume, can be defined as it is the amount of heat required to raise the temperature of the 1 mole of the gas by 1 degree Celsius. That means formula that is given by du by dt. That should be equal to d by dt of u. U is obtained here, 5 by 2 RT. 5 by 2 is constant, R is a number, constant. Only the temperature goes on changes as we supply the heat. So therefore Cv that should be equal to 5 by 2 into R into dt by dt. The value of dt by dt is nothing but 1. So therefore Cv that should be equal to 5 by 2 into R. So this is the value of Cv now. So Cv value ನಿಮಗೆ ಸಿಕ್ಕಿದ ನಂತರ hence what is the formula for the Cp now? We know that ನಮ್ಮ ಹತ್ರ ಒಂದು ಫಾರ್ಮುಲಾ ಉಂಟು. We have from AS equation Cp minus Cv is equal to R. So therefore Cp that should be equal to Cv plus R. That should be equal, what is Cv? 5 by 2 R plus R. That is nothing but 7 R by 2. This is the value of Cp now. Cp value ಗೊತ್ತಾಯ್ತು. Cp is equal to 7 R by 2. And hence, what is the formula for the gamma now? Gamma equal to Cp by Cv. Ratio of the specific heat. Value of gamma. Gamma is nothing but ratio of the specific heat. So Cp by Cv. That should be equal to Cp value 7 R by 2. The full term divided by Cv 5 R by 2. So 5 R by 2. 7 R by 2 by 5 R by 2. That should be equal to, so on solving this one, 2 to get cancelled, R get cancelled, so therefore 7 by 5. That should be equal to gamma. So this is a way of obtaining the gamma as well as Cp as well as Cv for the diatomic molecule which are rigid rotator. Rigid rotator word ಇದು ಕ್ಲಿಯರ್ ಆಗಿ ಐಡಿಯಾ ಗೊತ್ತಿರಬೇಕು. ಕ್ವಶನ್ ಕೇಳುವಾಗಲೇ ನಿಮಗೆ ಯಾವ ರೀತಿ ಕ್ವಶನ್ ಇರ್ತದೆ ಅಂತ ನೋಡಿಕೊಳ್ಬೇಕು. Rigid rotator means they do not having a vibrational mode. So H2 N2 these are the example for the rigid rotator. They do not vibrating even at the room temperature. So for that the value of Cp, Cv as well as gamma that should be equal to 7 by 5. So this is a value of gamma. In a similar way, we have to obtain the value of the molar specific heat as well as gamma for the diatomic molecule having vibrational mode. Now next iteration is the having the vibrational mode. Considering vibrational mode. Same iteration. Considering vibrational mode. So ಈ ಇದಕ್ಕೆ ಕೇಸಿಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಹೊರಟ್ರೆ ಈಗ. Now next iteration is like this. Same derivation, but we have to consider the vibrational degrees of freedom now. Now, considering the vibrational mode, we know that let us consider the diatomic molecule which having a temperature T and energy associated with each translational as well as rotational degrees of freedom. That should be equal to half kBT, and we have to write it for energy associated with each vibrational mode. Now next is the energy associated with each vibrational mode. What is energy? How much is energy associated with each vibrational mode? We already discussed it. So energy associated with each vibrational mode that should be equal to kBT, because vibrational mode includes the potential energy as well as kinetic energy. So therefore we have formula is that should be equal to kBT. Now suppose if we consider the diatomic molecule, for the diatomic molecule having vibrational mode has 3 translational, 2 rotational and 1 vibrational degrees of freedom. So it has a 3 translational, note down 3 translational, 2 rotational and 1 vibrational degrees of freedom. So carbon monoxide ಎಲ್ಲ ಹೀಗಿರ್ತದೆ, ಅದಕ್ಕೆ 3 translation, 2 rotational and 1 vibrational degrees of freedom. ಹಾಗಾದರೆ ನೀವೀಗ ಎವರೇಜ್ ಎನರ್ಜಿ ಈ ಕೇಸಲ್ಲಿ ಬರೀತಾ ಹೋದರೆ, ವಾಟ್ ಇಸ್ ಎವರೇಜ್ ಎನರ್ಜಿ ನಾವು? ಸೊ ಎವರೇಜ್ ಎನರ್ಜಿ ಆಫ್ ಎ ಮೊಲಿಕ್ಯೂಲ್, ಡೈಅಟಮಿಕ್ ಮೊಲಿಕ್ಯೂಲ್, ಒಂದು ಟ್ರಾನ್ಸ್ಲೇಷನ್ಗೆ ಹಾಫ್ kBT. ಹಾಗಾದರೆ 3 ಇದಕ್ಕೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದೆ, 3 into half kBT. Along with this 2 rotational, ಒಂದು rotationalಗೆ half kBT, ಹಾಗಾದರೆ 2 into half kBT and 1 vibration degrees of freedom, ಹಾಗಾದರೆ ಒಂದೊಂದಕ್ಕೆ ಎಷ್ಟು kBT ಹೀಗೆ ಬಂತು. Therefore on solving this one we can write it as 3 by 2 kBT, that should be equal to 3 by 2 kBT, ಅದಾಯಿತು, plus here the 2 to get cancelled, so kBT plus kBT, so kBT plus kBT 2 times kBT. So therefore on solving this one we can write it as kBT is taken outside, so therefore 3 by 2 plus 2, 3 by 2 plus 2, that much kBT, that should be equal to 4 ಆಯ್ತದು 7 kBT by 2. This is the average energy value. Now this if you write the for the 1 mole of a molecule, for 1 mole of the molecule, 1 mole containing Avogadro number of atoms, for the 1 mole ಗೆ ಬರೀತಾ ಹೋದರೆ ಆವಾಗ ಟೋಟಲ್ ಎನರ್ಜಿ ವ್ಯಾಲ್ಯೂ This is the average energy value. Male in the case average energy value. So this is average energy. Now if we write it for the 1 mole containing the Avogadro number of molecules. So therefore total energy value that should be equal to 7/2 into Na into Kb into T. ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ ಮೆಥಡ್ ಇಲ್ಲಿ ಉಂಟು. ಹೇಗಂದರೆ 1 moleculeದು ಎವರೇಜ್ ಎನರ್ಜಿ ನಮಗೆ ಸಿಕ್ಕಿದ್ದು 7 kBT divided by 2. And if we consider the Na number of molecules, Avogadro number of molecules, what is the energy? Na ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. So this is a way of obtaining the total energy now. So therefore, ಹಾಗಾದರೆ ನಿಮಗೆ Na into Kb, what does the term Na into Kb will indicates? Na into Kb will indicates the R. So therefore the U that should be equal to 7/2 RT. So U equal to 7/2 RT ಅಂತ ಬಂತು. This is the value of total energy now. Total energy ಗೊತ್ತಾಯಿತು. And hence what is the formula for the CV now? Hence CV, molar specific heat. CV can be defined as du by dt. So therefore that should be equal CV, that should be equal to d by dt of U. U value is obtained 7RT by 2. Here T goes on changes as we supply the heat. So therefore 7R by 2 is taken outside, dt by dt. That is nothing but 7R by 2. That should be equal to CV. So therefore CV is equal to 7R by 2. This is a molar specific heat at constant volume. Hence Cp. What is the formula for the Cp? So Cp minus Cv is equal to R. So therefore Cp that should be equal to Cv plus R. So therefore that should be equal to 7R by 2 plus R. That should be equal to 9R by 2. This is the value of Cp now. So we obtain another value, molar specific heat at constant pressure. Hence, what is the formula for the gamma now? What is the formula for the gamma? Gamma is nothing but ratio of the specific heat. So therefore Cp by Cv, that should be equal Cp 9R by 2. Okay, 9R by 2 divided by full term divided by Cv. Cv value, what is the value? 7R by 2. 7R by 2. That should be equal to 2 get cancelled, R get cancelled. So therefore 9 by 7. So this is a way of find outing the gamma as well as the Cp as well as the Cv for the diatomic molecule having vibrational mode. ಇಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ನೋಡಿಕೊಳ್ಳಿ, ವೈಬ್ರೇಷನಲ್ ಮೋಡನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ನಾವು ಡಿರೈವೇಷನ್ ಮಾಡಿಕೊಂಡು ಹೋದು. ಸೊ ವೈಬ್ರೇಷನಲ್ ಮೋಡ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ನಿಮಗೆ Cv ಮತ್ತು Cp ಮತ್ತು ಗಾಮದ ವ್ಯಾಲ್ಯೂ ಬೇರೆ ಬರ್ತದೆ. ಸೊ ಇದೆಲ್ಲ ಆ್ಯಕ್ಚುಲಿ ಯಾವುದಕ್ಕಂದರೆ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್. ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ molecule, we have to consider the vibrational degrees of freedom, translational degrees of freedom as well as rotational degrees of freedom. So this is a way of obtaining the gamma. So gamma value you have to remember, formal list ಅಲ್ಲಿ ಇದನ್ನು ಬರೆದಿಟ್ಕೊಳ್ಳಿ, and ಈ formal value ಅನ್ನು ಬರೆದಿಟ್ಕೊಳ್ಬೇಕು, and gamma value for the diatomic molecule having the vibrational mode. Now in a similar way we have to derive the expression for the polyatomic molecule. Now let us derive the expression for the gamma for the polyatomic molecule. Now next derivation is for the polyatomic. For the polyatomic molecule, what is the gamma as well as the Cp as well as the Cv? Let us consider the one polyatomic molecule. Consider polyatomic molecule. Polyatomic molecule more than 2 atoms. So polyatomic molecule at a temperature T. At a temperature T. Now we know that the energy associated with each translational and rotational degrees of freedom. Each translational and rotational degrees of freedom, that should be equal to half kBT. This is according to the law of equipartition of energy. According to the law of equipartition of energy, the energy associated with each translational as well as rotational degrees of freedom, that should be equal to half kBT. And also we know that the energy associated with each vibrational mode, each vibrational degrees of freedom. What is our value? ಒಂದೊಂದು ವೈಬ್ರೇಷನಲ್ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮಿಗೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುವಂಥ ಎನರ್ಜಿ ವ್ಯಾಲ್ಯೂ ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು KBT. ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಮತ್ತು ರೊಟೇಷನಲ್ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮಿಗೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುವಂಥ ಎನರ್ಜಿ ಹಾಫ್ KBT, ವ್ಯಾರಸ್ vibration degrees of freedom ಗೆ distribute ಆಗುವಂಥ energy that should be equal to KBT. Now polyatomic molecule, how much it will have a degrees of freedom? Polyatomic molecule has 3 translational, it will have a 3 translational, 3 rotational and F number of vibrational degrees of freedom. F number of vibrational degrees of freedom. This is very very important. It will have the 3 translational, ಒಟ್ಟು 3 translation ಉಂಟು, 3 translation ಉಂಟು, 3 rotational. It will have a 3. Diatomic molecule will have the 2 rotation degrees of freedom, but this will have a 3 rotation degrees of freedom, and it will have a F number. F ಅನ್ನೋ ನಂಬರ್ ಅದು, ಒಂದು 1 ಇರ್ಬೋದು, 2 ಇರ್ಬೋದು, 5 ಇರ್ಬೋದು, ಎಷ್ಟು ಸಹ ಇರ್ಬೋದು. ಸೊ ಪಾಲಿಯಾಟಮಿಕ್ ಮೊಲಿಕ್ಯೂಲ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ದೆನ್ ಆವಾಗ 3 ಟ್ರಾನ್ಸ್ಲೇಷನ್, 3 rotational and as well as F number of vibrational degrees of freedom. Now ಹಾಗಾದರೆ what is the average energy in this case? Hence average energy value in this case that should be equal to ಒಂದು ಟ್ರಾನ್ಸ್ಲೇಷನ್ಗೆ ಹಾಫ್ KBT, 3ಗೆ ಆದರೆ ಎಷ್ಟಾಯಿತು, ಸೊ 3 into half KBT and along with this 3 rotational, ಹಾಗಾದರೆ 3 into half KBT. Along with this F number, so therefore F into KBT. 3/2 plus 3/2 plus F number, ಹಾಗಾದರೆ ಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಹೊರಟ್ರೆ that should be equal to 3/2 ವ್ಯಾಲ್ಯೂ ಒಂದು, ಇನ್ನೊಂದು 3/2 and the F number, F that much KBT. So 3/2 plus 3/2 ಇದೆಷ್ಟಾಗ್ತದೆ 6/2. 6/2 is 3 plus F ಅದು into KBT. This is the average energy now. So average energy value of a one molecule, that is should be equal to 3 plus F into KBT. And if we write it for the 1 mole, for 1 mole of a molecule, for 1 mole the total energy value, what is the value? Total energy U, that should be equal to 1 mole containing the Avogadro number of atoms. So therefore we have to multiplying by Na, Avogadro number, 3 plus F ಅದು into Na into Kb into T. But Na into Kb will indicate the R. ಇದು ಆ್ಯಕ್ಚುಲಿ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ ಮೆಥಡ್ಸ್ ಗೊತ್ತಿರ್ಬೋದು. Na ಹೇಗೆ ಅಂದರೆ, ಅದು ಆ್ಯಕ್ಚುಲಿ ಹೇಗೆ ಅಂದರೆ 1 molecule ಎವರೇಜ್ ಎನರ್ಜಿ 3 plus F into KBT. ಹಾಗಾದರೆ Avogadro number of molecules ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ what is the energy? So this is a way of solving this one. So therefore 3 plus F into Na into Kb into T. So therefore hence U value, Na into Kb is nothing but R. So 3 plus F into R into T. So this is a value of total energy now. So total energy ಇಷ್ಟಾದರೆ hence CV. What is the formula for the CV? ಆಗಷ್ಟೇ ನಾವೆಲ್ಲ ಮಾಡಿಕೊಂಡು ಹೋದರೆ CV value, that is nothing but du by dt. Amount of heat required to rise the temperature of the 1 mole of the gas by 1 degree Celsius. So therefore CV that should be equal to d by dt of U ಅಂದರೆ ಇಲ್ಲಿ ಉಂಟು 3 plus F ಅದು into RT. So F is a number of vibrational degrees of freedom. So therefore R is a constant. So therefore ಆವಾಗ ನೀವು ಇದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡ್ತಾ ಹೋದರೆ, if we differentiate in this term we get CV that should be equal to 3 plus F is taken outside, ಅದು into R into dt by dt, that is equal to 3 plus F into R, that should be equal to CV. So this is the value of CV now. Hence we know that formula Cp minus Cv is equal to R. So therefore Cp that should be equal to Cv plus R, that should be equal to 3 plus F ಅದು into R plus R. So this is a formula 3 plus F ಅದು into R plus R, that is nothing but how much? ಇದು 3 R ಆಯಿತು, ಮತ್ತು ಇಲ್ಲಿ 1 R ಆಯಿತು, so 4 R. So 4 plus F into R, that should be equal to Cp now. So Cp is equal to 4 plus F into R, whereas Cv 3 plus F into R. Hence gamma equal to Cp by Cv, that should be equal to 4 plus F into R divided by 3 plus F into R. That should be R cancel. So therefore 4 plus Cf divided by 3 plus Cf. So this is a gamma value for the polyatomic molecule. ಹಾಗಾಗಿ ನಿಮಗೆ polyatomic molecule ಇದ್ದ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟಲ್ಲಿ ಬರೆಯುತ್ತಾ ಹೋಗಿದ್ದಾರೆ ಒಂದು ಈ ಫಾರ್ಮುಲಾ ಬೇಕು. You have to remember this formula. Cv is equal to 3 plus F into R. Cp is equal to 4 plus F into R, whereas gamma is equal to 4 plus F by 3 plus F. And if we consider the particular polyatomic molecule, and if we know the vibrational degrees of freedom, that is nothing but F, then we can correctly calculate the value of gamma. So this is a way of solving the Cp, Cv as well as the gamma value for the polyatomic molecule. ನಾವು ಒಂದು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕಾದ್ದು ಒಂದೊಂದು ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಎಷ್ಟೆಷ್ಟು ವ್ಯಾಲ್ಯೂ ಎನರ್ಜಿ ಅಂತ ಮತ್ತು ಎಷ್ಟು ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಉಂಟು ಅಂತ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾದರೆ ದೆನ್ we have first of all we have to calculate the average energy, and afterwards we have to calculate the total energy for the 1 mole and Cp as well as Cv. So this is a way of obtaining the Cp, Cv as well as gamma for the polyatomic molecule. Hope you understood this derivation. Thank you.